Hi, good morning, good afternoon, everyone. My name is Garrett Walsh. I'm the product manager for the control and monitoring products here at nVent Thermal. Today, we're going to be taking a look at the UIT loader spreadsheet. Now, what this is, the NGC-30 and NGC-20 families, if you're in Europe, uses a touchscreen called the UIT, and that stands for User Interface Terminal. Now, one of the key benefits of this UIT is you're able to get full read and write access to the controllers, and there's a USB port on the side of that UIT. This spreadsheet allows us to pre-program the controllers ahead of time and save them as a .xml file. This .xml file can either be put on a flash drive or it can be emailed to a client where they can put it on a flash drive. You can plug that into the back of the UIT and you can upload all of the programming for all of the controllers connected to that UIT in a matter of seconds. So this is a huge benefit because it greatly reduces the amount of commissioning time that's required in the field. It also helps because in general, you can get the person that designed the heat trace circuit to design the programming. This makes sure that cuts down on errors when it comes to programming, and also make sure that the person that's programming it knows what programming settings it should be set at because they're the one that actually designed the circuit. So to get started, as you can see, this is an Excel-based spreadsheet. When you come to this, what you're going to want to take a look at, first of all, is over here in cell B8. You want to make sure that the information that you enter is the right temperature unit. By default, the UIT is shipped with a degrees C for the temperature unit. So if you're in the United States or somewhere else, say in Latin America, where you want to program everything in degrees Fahrenheit, be sure to change this degrees C to degrees F. Now that that's done, we can focus lower down on the spreadsheet. All of the information here under system information as well as system setup, you can leave that completely alone. That will load whenever you program into your NGC-30. Really, the only thing that you're going to have to take a look at is this temperature unit, just to make sure that if you're wanting to program in degrees Fahrenheit, that you let the UIT know. The rest of this can remain the same. Then looking down, what we have is multiple headers here that define kind of a broad category of parameters. The first here is the setup circuit screen. Scrolling to the right, you have the RTD screen, then the temp screen, the ground fault screen, current screen, voltage, PLI, PASC, and maintenance screen. There are two more listed over here, but I'm not going to be going into them today because as you can see below, it says it's the European version only. Now, that may sound like quite a bit, but in reality, the vast majority of these aren't going to be needed 99% of the time. There's really only a few things that you need to enter for every circuit. So first of all, let's take a look at the circuit screen. So in here, this first column is the circuit number. This is going to be numbered 1 through however many circuits that you have. In this example, we're looking at a 10 circuit setup. So there's 10 circuits here. Next is your circuit ID. This is the name that you want to name that circuit. So you can see in parentheses over here, that's up to 40 characters. You can name a circuit anything that you want to name it. Right here, we call it circuit 1. I can also say it's HT101, HT301. It can be whatever you want. So some people prefer to name it after the heat tracing isometric drawing number, so they know exactly what heat trace ISO to look at. Some people name it after the line number, which is sometimes helpful for operations because it lets them know This is a heat trace circuit on a specific line, and they can know what process fluid is on the inside. Or you can name it circuit breaker 1. You can really name it whatever you want, just whatever is going to be most helpful to the customer. And so that applies to all, however many circuits you have. To the right of this, you have what says input required, circuit enable or disable. What this does is, as long as you're using that controller, this should be set to enable. The only time this would be disabled is anytime you have a spare controller. If you have a spare, then you can go ahead and disable it. But in this example, we're using all 10 controllers, so everything is set to enable. The next two columns are relay address and relay number. The NGC-30 runs off a CRM or a CRMS printed circuit board. And what that is it groups 5 controllers on every board. That's why the NGC-30 always comes in groups of 5. So you'll notice on here, we have relay address, and the first 5, the relay address is 1. And then the relay number just goes in sequentially 1, 2, 3, 4, 5. Now, really what that's trying to tell us is the first 5 circuits are on CRM board 1, and then circuit 1 is on CRM board 1, relay number 1. Circuit number 2 is on CRM board 1, relay number 2, and on and on and on. Once you get to circuit 6, rather than being relay board 1, relay number 6, now you go to a new board because every board is in groups of 5. So circuit 6 has a relay address of 2 and a relay number of 1. So going down, once we get to circuit 10, we finish with relay address 2, relay address 5. This is really important that you get this correct, because this is how the UIT assigns an address to each individual controller. It's all by relay number and, relay address and relay number. Next over here is the control mode. The majority of times what you'll be using is an auto on off, which is just a standard deadband control mode. But there are other options in here, such as always on, always off, PASC, voltage, which is anytime you have a CVM, or proportional. If you aren't sure what the control mode should be, my suggestion would be go ahead and just leave that as auto on off. This next column is the failsafe state. When you click over here, there's a drop down and you have 2 options. There's power on and power off. What this section is talking about is if your controller were to ever lose communication with the RTDs that it's controlling off of, what sort of behavior do you want the circuit to? So if you had a process temperature fluid and you're measuring that process temperature on an RTD, and someone were to come along and cut that RTD so that the controller doesn't know what the temperature is, do you want the circuit to turn off or do you want the circuit to turn on? For most hydrocarbon applications, the default is you want this to be power off, meaning that the circuit remains off until it receives a temperature from an RTD. The thought being is that you don't want to create a safety hazard where a heat trace circuit is on when it doesn't need to be. The one exception to that is if you have, for certain processes, you might want to have the circuit on if it loses communication to its RTD. An example of this is if you have self-regulating cable that's on a water line, for example, you may find that even if the cable were left on when it doesn't need to be, it isn't going to raise that water enough to boil it. For that, you can select power on. And there's a few other applications where the process customer would prefer to have it be power on, but in our experience, the majority of customers want the failsafe state to be power off. So that was the circuit setup screen. The next setup screen is the RTD section. Here is where you're going to select what RTDs you want to control off of. So by default, the very first section here, it says local/A. And what that means is by default, if a RTD is plugged into an NGC-30 controller, that NGC-30 controller is going to assume that it's controlling off that RTD. So on the very first example, we had circuit 1. We said its relay address was 1, relay number was 1. That corresponds over here similarly to RTD device address and RTD number. So here we've said 1, 1, and we've set the RTD mode to control. What that means is circuit 1 is going to be reading off the RTD that's connected into 1, 1, or in other words, the RTD that's connected to itself, and it's controlling off of it. If you click down on this RTD mode, you have a few different options. You have control, you have monitor, and you have continuity. Continuity is specifically for the PLI system, so majority of applications you have are going to be for control. There are times you may only want to monitor an RTD, but I would say over 95% of the time you're just going to leave this as control. This next section, RTD device number, RTD device address and number is 1, 2, meaning it's reading off of the RTD plugged in directly to it. Same for circuit 3. Circuit 4 is where things are a little different. Here we had a relay address of 1 and a relay number of 4, but an RTD device address of 1 and a RTD number of 1. Now you may come across this whenever you have a freeze protection application. Right here, what this is telling me is that circuit 1 is actually an ambient freeze protection application, and that ambient RTD is plugged into controller 1. Now that we've gotten to circuit 4, we also have an ambient freeze protection application, and it's reading off the same RTD, which is the ambient RTD connected to 1, 1. So if you have freeze protection applications, it's common to see multiple controllers all reading off the same RTD. So going down, some of these are still controlling off of the RTD that's connected indirectly to them, but you can see here circuit 8, if I highlight that, that is also reading off of the ambient RTD, so you can tell that this is a freeze protection application. So that's how to set a local RTD A. But if you had a circuit with multiple RTDs, you can also fill out their information here on B, C, and D. The NGC-30 allows up to 4 RTDs per controller. So if you have 2, 3, or 4 RTDs on a specific controller, you just enter their information on the columns labeled B, C, and D. Next, under temp screen, we have the setup temperature, and that's located here. Remember, we said the temperature units are in degrees Fahrenheit, so be sure to match whatever the values that you enter here with the temperature unit up there. But as you can see, the majority of the circuits here have a 40-degree maintain, but there are a few with slightly higher degrees, 75, 80 degrees. You just want to make sure that you match the heat trace ISO that's designed for the circuit. Next is your deadband value. What this is every NGC-30 has what's, if it's set to have an auto on-off control mode, that's the standard deadband control mode, and that's a positive only deadband. So what that means here on circuit 1 that had a 40-degree set point, if the RTD or RTDs that the controller is controlling off of ever reach 40 degrees, the circuit will turn on here at 40 degrees, and it will stay on until it reaches 45 degrees, and then it'll turn off and it'll wait to cool back down to 40 degrees before turning back on. So this deadband is a positive only. And what that means is it will never allow the temperature to cool to 35 degrees before turning back on. It will always turn on at your set point and go your set point plus your deadband before it turns itself off. By default, the deadband is always 5 degrees, but you can change that value if you want to. Next values in here are high temp alarm and low temp alarm. Be sure to fill these in for your specific circuit. As you can see here, they're blank. Any value left blank in this spreadsheet will refer back to the default, and you can see that up here. So right now, if I were to leave this blank, the high temperature alarm for that circuit is going to be set to 300 degrees. Next is your low temp alarm. And again, be sure to enter the correct value for your low temperature alarm that you're wanting for your client. The one thing I do want to point out here is, remember circuit 4 we said was an ambient freeze protection application, as well as circuit 8. Be sure to update your low temperature alarm so that you're not getting a nuisance alarm here. So right now, we said that circuit 1, 4, and 8 are all ambient freeze protection applications, but 4 and 8 have a low temperature alarm of -99 degrees. It's reading off of an ambient RTD. So if it gets cold outside, then you want that on circuits 4 and 8, you will not be getting a low temp alarm unless it gets down to -99 degrees Fahrenheit. Circuit 1, since we left that blank, it's going to default to the default value of 10 degrees Fahrenheit. And that's actually going to cause a nuisance alarm for your customer, because anytime it gets colder than 10 degrees Fahrenheit outside, circuit 1 is going to show a low temp alarm. And that's not really a true alarm that they need to be worried about, because it's only measuring the ambient air. So on your freeze protection applications, be sure to update your low temperature alarm to prevent that sort of nuisance alarm for your customer. The next two columns are for high limit cutout. I'm not going to cover that here because it doesn't apply anytime you only have one RTD per controller. The last thing I want to mention here is this temperature alarm filter. Now what this does is, this is a filter, meaning a circuit has to be an alarm for this many seconds before it actually triggers an alarm state. By default, one of the things that you'll notice is the default value for this is 900 seconds, which is 15 minutes. Now it's good to have a temperature alarm filter on there just to prevent any sort of nuisance alarms, but in many cases 900 seconds is too high. So my suggestion would be set this value to be 15 seconds or somewhere in that range. And what that will do is for your high temp and low temp alarm values, the RTD needs to be either in high temp or low temp alarm for 15 seconds before it actually triggers an alarm at the UIT. So that's just something that's there. You want to add some buffer there to prevent nuisance tripping, but you don't want to leave it so long that a customer isn't aware of a situation that he needs to be aware of. Lastly on here, we have the ground fault screen. So in here, you set your ground fault current alarm and ground fault current trip values. By default, the alarms for here are 20 milliamps for the alarm and 30 milliamps for the trip, but you can change those values if you want to. There's more information after this ground fault setup screen, but for the most of these cases, these are really for specialty applications. And for the majority of these, the default values are going to be fine. The one exception to this is under here, under the setup maintenance screen. One thing I want to point out here is this power cycle start time and power cycle test interval. What I've done here under power cycle start time, power cycle is one of the features on the NGC-30 that allows it to turn all of its circuit on at a set interval just to see if there are any alarms, So it comes on for a few seconds, energizes the circuit, and then turns off after a couple seconds. This is a great feature because it allows the controller to test itself every day in the summer and let you know that there's an issue rather than finding out that there's an issue with your heat trace on the first cold day of winter. So my suggestion here, you'll notice the default for power cycle test interval is 0 hours, which means the power test is disabled. My suggestion would be go ahead and change this to be 24, meaning that the NGC-30 will energize itself every 24 hours, do a power cycle test to see if there are any alarms, and then shut itself off after a couple minutes. The other thing I've added here is I've staggered out the start of all of these power cycle starts by 1 minute each, just to make sure that the entire panel isn't kicking on all at once and possibly accidentally tripping the main circuit breaker. So I've started this. Circuit 1 will start at 6:01 a.m., then 6:02 for circuit 3, circuit 3 at circuit at 6:03, circuit 4 at 6:04, etc. So that's really the last thing that I would point out. There are more info screens here to the right, but again, this is the European only version. So I didn't get into everything on here, but for the vast majority of circuits, that's really the only thing that you're going to have to be looking at. So I hope this was informative to you. Once you've filled this out, what you can do, go back. I would suggest you look over all your information to make sure that it's been entered correctly. And what you can do is you can click this button up top to the left and say Export XML. Once you do that, you can save it as whatever name you want. My suggestion would be name it as the panel name and then give the day's date that you programmed it and save it as that .xml. Once that's saved as an XML, that XML can be, as I mentioned, emailed to a customer, or you can take it, put it on a flash drive, plug it into the UIT, and upload all that information just in a matter of seconds. We'll be covering that in another training video, but hopefully you found this to be helpful. And again, if you have any questions, please reach out to our technical support team. And my name has been Garrett Walsh. I'm the product manager. Please feel free to reach out to me directly as well. Thank you very much.